So in the last section this week, let's talk a bit about groups and periods. In the periodic table or on the periodic table, columns are considered groups. These are essentially the families that we talked about. Each column is going to represent a group that behaves similarly. Everything in a column is going to react in a similar way as the others in that column. And it's because they have a similar electron structure. Hydrogen's got one electron just kind of hanging out. Lithium's got one electron just kind of hanging out. Sodium's got one electron just kind of hanging out. It's really easy to lose that electron and become positively charged. And then it'll be attracted to a negatively charged ion. Now, there are 18 groups or columns in the periodic table. Your textbook may reference 6 as in 1, 2, and then 3, 4, 5, 6, 7. I'm sorry, it may reference 8 instead of 18. There are 18 total columns in the periodic table. So just be careful with questions like that from your textbook. Periods refer to the rows of elements in the periodic table. Chemical properties change as you move across the row. This metal does not behave the same as this inert gas. They are different. As you'll see in your labs, the radius of these atoms decreases as you go across. They hold on to those electrons more tightly, which makes them behave differently. Okay? Unlike the groups, the periods do not tell you much. They tell you a little bit about how active an element is. Periodic table can also tell you which will be the most active and which will be the least active, right? So notice that down and to the left is the most active metal. Up and to the right is the most active nonmetal. And so as we go to the left, you see an increase in metallic activity. As you go to the right, a decrease in metallic activity, right? Or a decrease in activity, essentially. As you go down, there's an increase in metallic activity, but a decrease in non-metallic activity. All that to say that elements over here are going to want to react with elements over here. The most active metals with the most active nonmetals. Or, in some cases, the nonmetals just like to react with one another. And so the periodic table shows this just based on the position. And that position is based on the electron structure. And it's the electron structure that's causing all of this, that's causing it to be active. Finally, in the middle here, we have what are called transition metals. They're between the first two groups and the last 6. Okay, this is why sometimes they only refer to there being 8 groups and the transition metals, or 18 groups if you count the transition metals. These include things that you think of when you think of metals: gold, copper, tin, zinc. And again, their electrons are more free to move around. And so they conduct electricity, they block light, they reflect light, so they look shiny. This is where you find everything that are Earth's natural magnets. Iron is in the transition metals. Iron is the easiest metal that can be made into a magnet. But also cobalt can be made into a magnet. And nickel. And those are all right around here in the periodic table. Down at the bottom, you will find the rare earth metals. This is where you have things like uranium and plutonium. And they technically belong in this little space right here, which would spread out the first two rows. You'd have the first two rows, and then those two. We just kind of took that out. These go here. But they behave similar to one another, so we just kind of stack them and put them at the bottom to fit them into the page. And so we barely just touched on the surface of what the periodic table can tell us about elements. And next week, we'll talk about how we can use the periodic table and what we know about electrons to talk about chemical reactions. Please let me know if you have any questions this week or if there's anything that I can help you with.